Hey guys, so we're going to have a little look at the trigonometry question on paper 2 of the mocks. Again, this is a little bit wordy. I think this, particularly the early bits in this, are a little bit unfair, but hopefully when we see them now we'll understand them. So instead of reading out all this, I'm just going to take the important information. So Marco here wants to find out the slant height of the bell tower. So he wants to find out the height here. So that's this here. And what he's going to do, he's going to stand at a point here, which is 94 meters away. So it's 94 meters away from the edge. And he's going to look up here, and that has an angle of 29.88. He's going to use this information to figure out the slant height here. Now it tells us that we're going to use the tan ratio. So this is a Sokotoa question. Although the second part here says, why are we wrong or inaccurate if we use Sokotoa? It's because that isn't a true 90-degree angle. It's close enough to a 90-degree angle. The Sokotoa should only be used with a 90-degree angle, so we're going to be slightly off here. So what I'm going to do is I'm going to just label my sides. This is my hypotenuse, right? This is my adjacent, and this is my opposite, because it's opposite the angle here. So what we need to do is we need to write out our tan ratio. So Sokotoa says tan is equal to opposite over adjacent. And what we are going to do is we're going to fill in all these values that we know. So we know the tan of 29.88 is going to be equal to my opposite, which is unknown here, over my adjacent, which is 94. And what we can do then is we can just get the opposite by itself, 94 times the tan of 29.88. And that's going to give me 54.01 meters. So the height here is 51.01 meters, but that's just an estimate because that's not a true 90-degree angle. So that's why we are not going to be completely accurate. Again, we're going to use this figure a little bit later on. So we'll just keep it there because it's going to be used in the very, very last part. Next bit actually isn't too bad, right? Takes a little bit of working out in part 1, but part 2 it tells us to use the sine rule, so we're going to have to use a different rule. Now it says, realised Marco's error and decided to take a second set of measurements. So this here, point A, is Marco's measurements, which the original one was 29.88. This here was 94. And it says Lucia's measurement started at point B, which is 45 meters here. So if this is 45 meters and the original was 94, that means this must be 49 meters. And it says that Lucia's measurements are 49 degrees from here. So we're asked to find BD, and it tells us BD is equal to 74.53. Prove it. So I'm going to call this X. This is what we're looking for. So I have this side and an opposite angle. To use the sine rule, I need this side and this angle then. So I need to figure out what this angle is here. Well, first thing I'm going to do is I'm going to figure out what this angle is here, because 49 and this are on a straight line. So if that's 49, then this one here must be 3, 1. And if I add both of those together, okay, and take them away from 180 because this is a triangle, I'll get the top angle there, which is 19.12. So now I have this side and this opposite. So remember, the sine rule says A over the sine of A is equal to B over the sine of B. So all I'm doing here is I'm going to fill out what I know. So A, and A is going to be my X, is what I'm missing here, all over the sine of 29.88 is equal to 49 all over the sine of 19.12. So I've done this over the sine of this angle is the same as this over the sine of this angle. And then to figure out what X is, I'm going to do 49 over sine of 19.12 times by the sine of 29.88. When I put that into my calculator, I get this here, which is 74.53. So I've proved that. Next one, we're going to use this answer in it, and we're going to figure out something a little bit different. So I'm going to get rid of all this here. And I'm going to scroll down. Now, I am going to need this part of the diagram here, so I'm going to redraw that just as a triangle. So I'll redraw it just as a triangle. So this here says, hence find CE, the slant height of the tower. So what we have here is we figured out that this was 74 point, let me just check it there. So 74.53. We know that this is 49 degrees here. Okay. And we know that this here is 45. Measures given. So we're looking for this. I'm going to call this an x. And if you think about it, I've got two sides of an angle, I'm missing the third side. It's not a 90-degree triangle, so I can use the cosine rule. I'm going to use the cosine rule for this. And the cosine rule says that a squared is equal to b squared plus c squared minus 2bc times the cosine of a. This is my a, what I'm missing. So I'm just going to put that there. So I'm going to write x squared, and the angle I use is going to be this angle here. So it's x squared is equal to b squared plus c squared. So it doesn't matter which order they go into. So 74.53 squared plus 45 squared minus 2 times 45 by 74.53 times the cosine of the angle, which in this case is 49 degrees. That can all go straight into your calculator. And you're going to end up with x squared is equal to 3179. And when you get the square root of that, that's x squared, x equals square root of 3179, you're going to get 56.4. So the actual height is 56.4. It says find the percentage error Marcus calculation of the slant height of the tower. So this goes back to part 1. We worked out a height. So our first value for the height was 54.01. Our second accurate value was 56.4. So what we're going to do is we're just going to take them away from each other to find the error. So the error is 2 and then minus. That was my original calculation, which was inaccurate. That's my actual calculation there. So the inaccuracy there when I do 56.4 minus 54.01 is 2.39. So it's 2.39. Them two taken away from each other. And then what I do is I do 2.39 over my my actual, which is 56.4, and I times it by 100. And that gives me 4.24%. So the percentage error we was out was by 4.24%.